Okay, everyone, it's 12:30 and I'm going to start the lecture. I hope all of you had great break. And before I start the lecture, your SI Pass leaders want to make an announcement. So let's hear what they're going to tell us.
Hey guys, just so you know, this week Sydney and I are both holding an extended session. So note the changes on the board. My extended session will be held on Tuesday from 4 to 5:50 in the TLC room 148.
And then mine is on Wednesday, also from 4 to 5:50 in my normal room, TLC 150. And then both of our extended room sessions are going to be focused solely on reviewing for your exam next Monday.
Okay. Thank you.
Thank you guys.
Okay. 0:50. So Sydney, what is your extended hours?
4 to 5:50 on Wednesday.
Oh, okay. So both they are 4 to 5:50, but one of them on Tuesday, the other on Wednesday, and TLC 148 and 050. Okay, I also wrote that in the board for people at home, so they are aware of that. So before starting the lecture, based on the performance of previous homework, I just want to give a TED talk before starting the lecture. So as you see with your performance in the homeworks, as we progress, the average of the homeworks become lower and lower. And if you don't study for this class, and if you're already having like D and F, most probably you're going to fail. But because I don't want to fail any students and I care deeply about all of you and about your GPA, I have like extra credit opportunities for going to SI Pass or tutoring, and I give 5 points to just attending the sessions. So technically, if you have like unlimited time, by just going to SI Pass, you can pass this class or like get an A. But I'm sure it's not feasible for people to just go like to SI Pass sessions, right? Or like tutoring, all the hours in the week. So it would be like more limited. And also, last semester I was really lenient towards the students because I joined University of Idaho in the middle of the semester. It was really tough transition for students. So I gave them extra credit assignments, which this semester you have as part of your class. And since they are open book, open notes, open resources for like your homeworks and quizzes, it's basically 500 points that you can easily gain. So for that matter, I'm not going to give any extra credit opportunities on, just tutoring and SI Pass, which I think is generous enough, right? Just, you go 1 hour of tutoring or SI Pass, you get 5 points. So I think that is pretty fair. So all this being said, I just want to encourage you to study. And I feel like the lectures are not super complicated, and it becomes complicated when you don't study, right? So I just keep, throwing information at you, and if you don't study, next session would be difficult. And if you didn't study last session, now this class, you don't have any idea what is mole, how to convert moles to grams. And now I'm going to add more information, and I'm trying to cover the whole lecture today for your lab or students, most of you that have lab tomorrow, so you know how to deal with that lab. So basically study, and if you have any questions or difficulties, just reach out to me. I had some students that came to me and, like weeks ago about the concerns that they had with the class, and I told them to just go to SI Pass, and by going to SI Pass, their grade was C, but their midterm was B. So basically 1 letter grade, they increased their grade just by going to SI Pass. So if you're struggling with the class, I highly encourage you to go to SI Pass, tutoring, or just reach out to me and I work out with you and make sure that you're up to date with the class. But if you don't study, unless you know all these materials, it's really likely that you fail the course, and I don't want that to happen. The other thing is that I have multiple versions for homeworks, and as you saw, based on the solutions that I posted, you had like 6 different versions for the previous homework. and I posted all the solutions on Canvas. So just study those questions, and if you have any questions, just email me, because chances are you see the exact same questions on your exam. And as a matter of fact, for your quiz 3, I repeated like some of the questions just from those homework assignments. And you took one version, so there are like 5 other versions to study, so I don't see why you shouldn't study those, and you may see the exact same questions on your quiz and your homework. So any questions with that? And the other thing that I wanted to mention, so this is like after break, lots of you traveled, and just to be safe, I asked you that if you stop by my office, just wear a mask for both of us to be safe. And I have like extra masks at my office, but I have almost like 200 students, so if I just like give students one mask at a time, I cannot afford to have that many masks. So yes, any questions just with these things that I just mentioned? Okay, if no questions, I'm going to briefly review the previous things that we talked about, and as I said, I really want to progress with the lecture today, so I cover all the materials that I want to cover. So one thing that I quickly go through is ionic compounds, molecular compounds. So ionic compounds composed of cations, anions. Can anyone tell me what is an anion? Yes?
The negatively charged particles.
Exactly. So if I just tell you chlorine atom, and it's just like group 17, 7A, over there, you see chlorine, atomic number is 17. If I just tell you chlorine atom, it has 17 protons, 17 electrons, and it's neutral. But if chlorine gains 1 electron, it becomes Cl minus, and it becomes an anion. Right? So anion is a negatively charged particle. So what is a cation? Positively charged particle. For instance, Na plus is a cation. So ionic compounds are anions plus cations. And most of the time, 99% of the time, there would be a metal plus non-metal. And the only, so metal plus non-metals are ionic compounds. You have only one exception here, which is NH4 plus ammonium, which is a cation, but is not a metal. So if you have cation plus, if you have NH4 plus a non-metal or polyatomic anion. This is also an ionic compound. So if you see metal plus non-metal, it's for sure ionic compound, unless you have NH4 in the structure. So NH4OH is also an ionic compound, because it is cation plus anion. Does that make sense? So this is ionic compounds. Molecular compounds are 2 or more nonmetals, or a metalloid plus nonmetal. So if you don't see a metal in your compound, it would be a molecular compound. Okay, and I still didn't cover acids, but I covered that during the next sessions, because as I said, I want you to be caught up with the lab. So first I'm covering this part of the course, which is chapter 6. Answer my question. If I ask you what is molar mass of fluorine atom, and remember that fluorine by itself in nature is F2. So if I just say you tell fluorine, you should consider that F2. But if I tell you specifically just one fluorine atom, right, it would be just like this fluorine here. So what is molar mass of one fluorine atom? What is it? Anyone?
35.45 grams per mole.
So, fluorine, right?
Oh, sorry, 19 grams per mole.
Exactly, yes. And you know, this is something that happens in the exam too. You know, students know the answer to the question, but they look at the wrong thing. So she knew the answer, but she accidentally looked at this one. So pay attention in the exam, because most of the time you know the answer, but you make it. So what is the unit? Molar mass. Grams per moles. And remember that molar mass numerically equals atomic mass unit. You see that this number is atomic mass that has the unit of atomic mass unit. But if I ask you molar mass, the unit would be gram per mole. But if I ask you the atomic mass, the unit would be atomic mass unit. Does that make sense? The numbers numerically are the same, but the units are different and they represent different things. So make sure to know the differences. But in your exam, any question that you want to solve and you want the molar mass of the element, you just look at the number listed below, basically atomic mass. But remember, the unit would be gram per mole if I ask you for molar mass, because it's mass of 1 mole of the element. Does that make sense? And again, here you see metals, right, with this color, whatever you call that. And then this is like metalloid. These are non-metals. So non-metals are like hydrogen and like these guys here, right? And these are your metalloids in this zigzag here, and the rest are metals. So you know, in the exam, I give you a black and white periodic table, so you cannot see which one is metal, which one is non-metal. But by now, I expect you to know. Okay? Any questions? So you can, and oh, and again, this group, you know, as you see, you know, every lecture I include these slides because these are really important, and I, you know, ask you and I expect you to know these group names, and I ask you in the exam which of the following is not an alkali metal, okay? Which one of the following is not a noble gas? Also, so you have it. Okay. So can anyone tell me what is the numerical value of Avogadro's number? Anyone? You have it here. Just anyone? Yes.
6.022 times 10 to the 23.
Exactly. So this is extremely large number, and you know, remember 6.022 multiplied by 10 to the power of 23 of anything, it would be like 1 mole of that thing. So this is like the definition of mole. So if I say I have 1 mole of pennies, can anyone tell me what this sentence means? Yes?
It means you have 6.022 times 10 to the 23rd amount of pennies.
Exactly. So it can be about anything. It's not only in chemistry context. It's just like 6.022 multiplied by 10 to the power of 23 of anything. So, and you should remember this number. Periodic table, let me go. Okay. So, can you, the guy that was just talking, so can you just tell me that what is 1 mole of books? Is this a large number or small number? Why? Exactly, because as we just mentioned, is 6.022 multiplied by 10 to the power of 23. As your friend mentioned, this is an extremely large number because it's 10 to the power of 23. So if we have, and here I again included this slide, if you have 22 copper pennies, this would be 1 mole of copper atoms. And it can tell you how small atoms are. And if you have 1 mole of pennies, the other thing is that the numerical value of the mole is defined as being equal to the number of atoms in exactly 12 grams of carbon-12. So can anyone tell me, what does carbon-12 mean? Carbon-12. What is 12? Yes?
12 is the mass.
Exactly. So this is the mass of carbon-12 because, you know, as we said, there are different atoms for each element. Some elements, they have like different atoms that they have the same number of protons because for each element, the number of protons is the same, but they have different number of neutrons. So the mass for different atoms may differ. So this one, we refer to carbon-12, meaning that the mass of carbon atom that is 12. So this is where the numerical value of mole comes from, and I'm going to ask you in exam whether true or false or which of the following statement is not correct or correct. So make sure to know this definition really well. Any questions so far? And as I mentioned during the last sessions, you know, if I see anyone talking, I ask them questions because this is the only way that I can stop students from talking. So if you have any questions, just feel free to ask me because I don't want any other person be distracted. To the period, it's as we mentioned before, and I kind of like underlined it last session too. If you have 1 mole of pennies, it covers the entire of the Earth planet to the depth of 300 meters. So it can tell you this how large this number is. So atoms, molecules are really small, and 1 mole is really, really large number. And go to what? Okay, so now I'm going to talk about more practical applications and things that we're going to use to solve questions till the rest of semester. So if you have any difficulties here, this is a really good time to ask me, because if you don't understand this, most probably you cannot solve any questions till the rest of semester. So we study a concept named molar mass. Molar mass has the unit of gram per mole. And it means that the mass of 1 mole of an element or atom or molecule, depending on what we're working with. So the mass of 1 mole of atoms of an element is its molar mass. So if I ask you what is the molar mass of fluorine atom, and they had here, for instance, if I ask you for like sulfur, the molar mass, you just look at the periodic table and then you see the number 32.06, right? Or for carbon is 12.01, and the same thing for lithium. And 1 mole of anything has 6.022 multiplied by 10 to the power of 23 of that thing. If I tell you 1 mole of ions, it would be 6.022 multiplied by 10 to the power of 23 ions. If it would be 1 mole of molecules, it would be that much of molecules. Any questions? So you have lots of questions like this in your homework 9 and quiz 3. So I encourage you to just go through the lectures and then make sure you know these concepts well. And this is an example that I'm going to briefly go through. So for instance, if you want to calculate the number of moles of sulfur in 57.8 grams of sulfur, right? So first you write what you are given, what you want to find. So if our exam wasn't multiple choice question, I would give you credits for writing your procedure, but fortunately or unfortunately it's multiple choice questions. So you should make sure to do all the procedure right, because I cannot give you any credit for the solution that you're writing. After that, you write the solution map, right? And then you determine what conversion factor you should write to solve the question. So we want to find number of moles, right? So we have grams, we want to find mole. And when we want to write the conversion factor, we should write it somehow that the denominator and numerator, they cancel out, and then we find out the mole, right? So this is how we write the conversion factor. Does that make sense? And then this number here, so mole over gram. What does this quantity represent? Anyone? So we have mass here, yes, but we also have mole. You're close, but not quite. So molar mass is gram per mole, right? This is mole per gram. So this is like 1 over molar mass, right? So when you write the conversion factor, instead of writing 32.06, you write 1 over 32.06. Does that make sense? Any questions? Okay, and then you just substitute the numbers. Again, we write the thing that we want to find. Here we say how many moles of sulfur equals 57.8 grams of sulfur. Multiply by a conversion factor, we write it somehow that gram and gram cancel out, and then we find the mole. And remember, molar mass says what is the mass of 1 mole of the thing that we're finding. So sulfur, 1 mole of that, the mass is 32.06. And then if you go to periodic table, or just look at the periodic table in the class, you see that 32.06 is listed below sulfur. And then the answer would be 1.8 moles of sulfur. Any questions? And for more examples, I encourage you to go to SIPass or tutoring so you get extra credit and also learn better. And your SIPass leaders have access to all your homeworks, and they solve really, on your quizzes. So they are basically on Canvas, so they can see everything. So that is a good thing about going to SIPass. So, the chances of them solving really similar questions to your homework or quiz is really high. Okay, now I'm going to start with the new lecture, which is chemical formulas as conversion factors. So if I tell you in one leaf, we have 3 clovers. And the online version of the book have some errors. So if I have 1 leaf, I guess I should have wrote leaf, not. Anyway, how many clovers are in 1 leaf? How many? 3, right? Or the other example. So 1 spider, how many legs the spider has? 8, right? Now I'm kind of like suspicious. Is it 8? Now I'm counting. Yeah, I think it's 8. So, I'm not going to ask you these in the exam, so you don't have to worry about them. But just like learning the concepts, or if I say like in this chair, one chair, how many legs this chair has? 4, right? So the same matter that we can kind of have these analogies, I can give you like hydrogen molecule, and I say how many hydrogen atoms are in 1 H2O molecule. So I tell you that, let me write it. How many hydrogen atoms exist in 1 H2O molecule? What is the answer? 2, right? To give you another example, if we have 1 CO2 molecule, and can anyone tell me the name of this compound, CO2? Carbon dioxide, right? Remember that if there is just 1 carbon the first element, if it's only one, we don't write mono, so we just say carbon. And then the second element, di, that represents 2, and then base name of the second element or second nonmetal, oxide. So oxygen would be, OXI plus, I guess, IDE. So it would be like carbon dioxide, right? Anyway, so in one carbon dioxide molecule, how many oxygen atoms I have? 2, right? So it would be 2 oxygen atoms. So mathematically, if I multiply both of these, so I have 2 oxygen atoms, 1 CO2 molecule. If I multiply both by Avogadro's number, 6.022 multiplied by 10 to the power of 23, I won't be changing anything, right? It's just like more of them. So I can claim that 6.022 multiplied by 10 to the power of 23 CO2 in molecules correspond to 6.022 multiplied by 10 to the power of 23 multiplied by 2 oxygen atoms. Or I can tell in this much of CO2 molecules, this much of oxygen atoms exist. Does this make sense to everyone? Any objections of what I wrote? Right? So we can multiply both sides of an equation by a number without the equation not being changed, right? Right? Okay. So, can anyone tell me what this number represents? 6.022 multiplied by 10 to the power of 23 CO2 molecules. Anyone? So I told, yeah?
1 mole.
Exactly. So 1 mole of anything is like 6.022 multiplied by 10 to the power of 23 of that thing. So if I write 6.022 multiplied by 10 to the power of 23 CO2 molecules, it would be 1 mole of CO2 molecules, right? What about this one? What does this correspond to? What is this?
That would be the molar mass of oxygen.
Yes, but just like in the sense of I just want to write an analogy. So here I wrote this as 1 mole of CO2 molecules, right? So for 6.022 multiplied by 10 to the power of 23, that is 1 mole, right? So now that is multiplied by 2, it would be 2 moles, right? So this would be 2 moles of oxygen atoms, right? So this is the takeaway message, that if you have the chemical formula that gives you information about moles of constituents. So if I tell you that I have like 1 CO2 molecule, it means that for like 1 carbon atom, I have 2 oxygen atoms, right? It also means if I just write CO2, it means that in 1 mole of CO2, I have 1 mole of carbon and 2 moles of oxygen. Does that make sense? So takeaway message is that if I give you like MgOH2, and this would be like a question, it was the question for the last exam last semester. So it was like I say that how many moles of hydrogen exist, and I write hydrogen atom so you won't get confused. How many moles of hydrogen atoms exist in 1 mole of MgOH2? Can anyone tell me the answer? 2, right? So in 1 mole of MgOH2, we have 1 mole of Mg, 2 moles of oxygen, 2 moles of hydrogen. So basically you count the number of atoms, and that would be number of moles if you have 1 mole of the compound. Does that make sense? Any questions? So for instance, if I say how many moles of oxygen exist, oxygen atom, exist in 2 moles of C6H12O6. Okay, so what you do, you write what you want to find, which in this case, you want to find how many moles of oxygen atom exist in 2 moles of CCH12O6. Any questions so far? So I just wrote what I want to find and what I have been given, right? And then I write a conversion factor. In the denominator, I write something so it cancels out. So I write moles of C6H12O6. And in the numerator, I write moles of oxygen, right? Because I want to find that. So can anyone tell me this ratio here? We look at C6H12O6. If I have 1 mole of C6H12O6, how many moles of carbon I have? Exactly, right? You just see this number. How many moles of hydrogen? 12, exactly. How many moles of oxygen? Right? Oxygen. So here, if I have 1 mole of C6H12O6, how many moles of oxygen I have? 6, right? So your answer here would be 12 moles of oxygen. So the takeaway message is that when I give you a chemical formula, you can have relationship between moles of constituent elements and also moles of your compound. Does that make sense? Let's do another example. So if I have NH4 and I ask you how many moles of hydrogen atom exists in 20, to change the question, moles of NH4. Can anyone tell me the answer? Exactly, right? Because you say how many moles of hydrogen equals 20 moles of NH4. You write a conversion factor, moles of NH4 cancels out with moles of NH4, then you write moles of H, right? And 1 mole of NH4 has like 4 moles of hydrogen, right? Because NH4 has 4 hydrogen atoms in 1 mole of NH4, right? So the answer would be 80 moles of hydrogen. Does that make sense? Any questions? Good. Okay. As I said, I always post all the lectures. So if you're like behind writing, don't worry, I post everything. And I also posted a study guide for chapter 4, and I'm going to post a study guide for chapters 5 and 6. So you have all the study guides for your exam. Okay. So now we learned about molar mass, right? And we learned that if we want to calculate, or if we want to read rather, molar mass of an element, we just refer to the periodic table, right? And we read the number below the element symbol. So if I have hydrogen, 1.01, it would be its molar mass. It is also atomic mass, but depending on the unit, it can be either. So it would be 1.01 gram per mole. So 1 mole of hydrogen, 1 mole of hydrogen has the mass of 1.01 grams, right? And if we had like compounds, we basically calculate formula mass, right? Does everyone remember how to do that? For instance, if we had, let me go here, hydrogen, how do you calculate formula mass? You say you have 2 hydrogen atoms plus 1 oxygen atom, right? And then you go to the periodic table, read these numbers, and then this is 16, right? And then it would be 2.01 plus 16, 2.02. It'd be like 18.02. So if it's formula mass, it would be atomic mass unit, the unit. If it's molar mass, it would be 18.02 gram per mole. This is molar mass. Does that make sense to everyone? And we also said that we can have a relationship between moles of elements. So we can say 1 mole of H2O has 2 moles of hydrogen in it. Or you can say 2 moles of hydrogen corresponds to 1 mole of oxygen. Or 1 mole of oxygen exists in 1 mole of H2O. I mean, depending on what I ask you in the exam, you write different ratios. But all of these conversion factors are correct. But if I give you a conversion factor, and it's like for H2O, I say 2 moles of hydrogen corresponds to 2 moles of oxygen, this conversion factor is wrong. Does that make sense to everyone? Okay, so knowing these things, you can solve so many questions, and this is converting grams of a compound to grams of a constituent element. Remember, you can never convert grams of an element to grams of a compound directly. We always talk in moles, because as I just told you, we can have a relation between moles of this compound with its constituent elements, but we don't have such a relationship between grams. So if I give you this sentence and say, is the following statement true or false? We can convert grams of a compound to grams of its constituent elements by only one conversion factor. That would be false, right? Unless someone comes to you and tell you that in NaCl, if they give you like the mass percent composition, and unless they give you the mass percent composition and directly you know the ratio, just by knowing the chemical formula, you cannot convert mass to mass directly. And how we do that? First, we convert grams to mole by molar mass, basically reverse of molar mass. But when you write the conversion factor, as long as you know how numerator and denominator cancel out each other, you're fine. But with the help of molar mass, you convert grams to moles by chemical formula. You convert moles to moles, and again by molar mass, because it has the units of gram per mole. Remember, molar mass has the units of grams per mole. With molar mass, you convert moles to grams. Does that make sense to everyone? Any questions? Okay, so let me stop here and solve one question so I make sure that this is clear. And I choose one example from the book so I don't have to worry about the numbers. So I'm going to solve example 6.7 from your textbook. And we have C10H14O as the compound, and it says calculate the mass of carbon in 55.4 grams of C10H14O. Can anyone tell me how should I start solving this question?
We need the formula mass for C10H14O.
Exactly, yes. So this is one thing that we should take care of. What else?
Write down what you need to find and what you're given.
Exactly. So we want to find mass of carbon, right? So write question mark how many grams of carbon equals the thing that you are given, right? 55.4 grams of C10H14O. So can I write this by the information given? Gram C10H14O to grams of carbon and solve the problem just like this? Remember, we should always convert moles to moles. This one we cannot do, okay? Because we don't have the information. If the problem tells you that C10H14O has 20% carbon in it, and it specifies that it's mass percent composition, you can do. But with the information provided, you cannot do that. We always convert grams to moles. C10H14O to moles of C10H14O. And as your friend mentioned, we should find molar mass of this compound, which is basically its formula mass. But you should remember that the unit is gram per mole. So if you go to the periodic table and look at carbon, the atomic mass unit is 12.01, and then for hydrogen, this number is 1.01, and then for oxygen is 16. Okay? And then you have 10 carbon atoms plus 14 hydrogen atoms plus 1 oxygen atom. Any questions writing this? And we substitute these numbers here. Okay? And when we do that, the final answer here would be 150.2. What is this unit here? I calculated molar mass. Grams per mole, right? It means 1 mole of this compound has the mass of 150.2. Okay? So here I write 1 mole of this compound has a mass of 150.2. Any questions so far? Is that clear? So now we got rid of grams of C10H14O. What is the next step? We want to find carbon, right? Grams of carbon. So how can I convert moles of C10H14O? In other words, how can I convert my compound to a constituent element? With chemical formula, right? So I convert moles of C10H14O to moles of carbon, right? Can anyone tell me how many moles of carbon exist in 1 mole of C10H14O? 10, exactly, because this number here is 10, right? So I write 10. So these two cancel out. Finally, how can I convert moles to grams? Molar mass, right? It relates grams and moles. Can anyone tell me what is this ratio? By looking at this. One mole of carbon has the mass of 12.01 grams, right? So this would be all the conversion factors that you need. So this equals 55.4 multiplied by 1 multiplied by 10 multiplied by 12.01 divided by 150.2 multiplied by 1, and the unit would be grams of carbon. And even when I'm writing your exam question, sometimes I forget to write one of these numbers because I didn't write them so neatly. So make sure to have all these numbers written here and put all of them in your calculator. And when you do the procedure, the final answer here would be 44.3 grams of carbon. And always check your answer. So the question was calculate the mass of carbon in 55.4 grams of your compound. If the answer was 100, imagine I solved the problem and I found 100 grams of carbon. Can anyone tell me what is wrong with this answer? Imagine after your exam, I tell you, so there are like roughly 120 students in our class. And after the exam, I tell you 150 students passed the course this semester. What is wrong with that? We have like more students. How is it possible that more students pass the class and the number of students? So here, your compound mass is 55-ish, right? So it's not possible that one of the constituent elements mass would be more than the mass of the compound. Does that make sense? So always check your answer, because if you get like 443 grams, you automatically know that the answer is wrong, and you can like eliminate some of the options in the exam by just looking at the options. So in your lab tomorrow, you're going to find an empirical formula, and we talked about empirical formula before, that what it represents. Basically, if you have like a molecular formula and you can simplify it further, that is not empirical formula. So the empirical formula would be CH2, for instance, in this instance, because it's like the smallest whole number ratio between the elements of a compound. So in your lab tomorrow, you're going to do the reverse of what we did today. I gave you the molecular formula or empirical formula, and I asked you what is the relationship between moles. For your lab tomorrow, your lab TA gives you grams of each of the constituent elements. You should find the moles of each of them and then write the empirical formula based on that. And I'm going to also post a quick video for your lab tomorrow, and I post that in your lab class, so it would be easier for you to do the lab. So I highly encourage you to watch that. And here, finally, the attendance. And make sure to do homework 9 and quiz 3 by Wednesday. And if you weren't in the class today, make sure to watch the video, because as I mentioned, these are like the building block of the course, and if you don't learn these materials, it's likely you cannot pass the class. So just reach out to me if you have any questions about any of the materials.